It is everything. Tomorrow's are art, never for sure. They're not guaranteed. We could all be kaput today, which I hope not. But my wife would be rich after that. But whatever. She's got life insurance. Brian, Brian. Thanks, Brian. Appreciate you, buddy. Depends on how much you pay in. By the way, your sister and my salary are totally different. No. How education works is steps and lanes. The more years you teach, the more money you get. The more education you have, the more money you get. That's how it works. Say what? I don't know what you said, but okay. Fruit snacks. Do you have fruit snacks? You said you're bringing me some. You're hurting my feelings. Okay, guys, here we go. Let's see if we can read this really well. Today, we're going to decide what type of different samples we have. We can collect data through samples. So our first kind is what we call a convenience sample. Okay, a convenience sample is just like, for example, last time when I did your guys' shoe sizes, that was a convenience because you guys were here in my classroom, right? I didn't go out to try to find random different people. I just picked Mr. Roberts' class because I was in here. You guys are a convenience to me. Does that make sense? Or, hey, people that are coming into a restaurant, that's their survey. That's convenience. No, remember, we're using the S of X. Yep. But we're not doing anything off of this anyway. Self-selected sample. That's kind of like when you go into a restaurant, and you guys know how they have those survey cards sometimes sitting on your table. Does that make sense what I'm saying? How they're like, rate us, please, or something like that. That's somebody going out of their way to complete that sample for you. You're not personally saying, hey, will you take a survey? It's just there, and they can take that opportunity upon themselves. Does that make sense? Or they go, hey, go on Yelp and rate us. Does that make sense? That's kind of more of a self-selected sample. That's sometimes why I don't like Yelp or those type of things, because it's you either get really good or you get really bad, right? Either person loved this or they completely hated it, right? Don't you ever look at those and that's kind of what you see? Because not everybody's being sampled. It's just the people that really maybe enjoyed it or somebody that really didn't enjoy it, right? Get what I'm going at there? Okay, a systematic sample. Now this is on your test, and this is probably the biggest part, is these four things right here that people mess up. Just knowing what is which. Okay, a systematic sample is saying, like, for example, let's say I have every student here in Westlake, okay? And then I say, okay, every 10th student on the list, I'm going to take a survey. It's systematic, meaning it's all alphabetized, systematic. Or you go randomly through a phone book like every 4 people. That's systematic. Does that make sense? An example of a systematic. Somehow it's very procedural. I will take the 5th person in line. Yes, no? Everybody good there? If I was doing a survey for the whole hall, I'm taking only the even numbered classrooms. Systematic. Okay? A random sample is the best sampling of all. A random sample is you just randomly pick people out of the blue. Maybe you put all of people in Westlake and you pull out numbers out of a hat. And those people would be it. That's the best type because it's completely random, right? There's not a bias to it. That's a word coming up. What does bias mean? As what did you say it was? A personal prejudice. I like that. Or it could be a good or bad bias, right? For example, on bias, like I'll be honest, when I first started grading tests when I was a younger teacher, I looked at names. Kids I liked, I graded nicer. Kids I didn't, I graded them harder. I did. And nowadays, I don't. I only front page is the only front page is the only time I see kids' names. After that, I don't see them, so I don't know who they are. And then I'm grading everybody the same. You know what I mean? So I kind of had a bias in grading. Does that make sense to everybody? I found that out to myself. I started looking at it. I'm like, oh, I like that kid. I minus only 1. And I marked this kid -4 on the same problem. They did the same work. It was bad. That's one reason to kiss the teacher's booty. Thanks, Cole. All right, onward. Okay. Any questions there? Now, we just talked about bias. Let's see here. Okay, let's look. Yes, sir. Okay. We have different type of sampling methods. We have public opinion, okay, which just a newspaper wants to find out what % of the city population favors a property tax increase to raise money for local parks. What is the sampling method used for each situation? Does the sample have a bias? Here we go. A newspaper article on tax increase invites readers to express their opinions on the newspaper's website. Is it have, what kind is it? Self-selected. Does it have a bias? I would think it does. Sometimes even our newspapers here in Utah, we have one that's a little bit more conservative and one's a little bit more liberal, right? I don't know if you guys know that, but they are. One has more of a liberal type of attitude towards it, and the other one's very conservative. They might not run the same stories because of their beliefs. Make sense? So this is a systematic or self-selected, and it might have bias depending on people that read that, because maybe even that newspaper is directing it towards a certain group. Does that make sense? Could be that way. Okay, let's try another one. A reporter interviews people leaving the city's park. Well, if they're talking about parks, and that is convenience, right? Is it biased if they're talking about, hey, let's add more parks, and you're interviewing people in the park? Yeah, because obviously those people enjoy parks, right? Does that make sense to everybody? Okay. Every 50th person is a systematic. Any questions there? Pretty easy. All right, now let's go over here. Well, how do I get that stuff? We'll go control down one. All right, now we have different types of studies. I can't go any bigger than that, so if you guys will just listen up. Observational study that's when you don't ask anybody, you're just observing them. Have you guys ever heard about those people that, like, you have like kids that will go play in a room and then they have that double-sided glass or that one-sided glass, they just observe what that child is doing with the toy or something like that. That's just mean, okay? Devin's mom must have did that. Okay, so that's an observational study. You're just observing what's happening. You don't talk to them. You don't do anything. You're not even really letting them know what you're doing. Sometimes that might be just sitting at a park bench and you're like, hey, and you're the creeper dude, but whatever. You know what I mean? Okay, a controlled experiment. Okay, how many of you guys have ever heard, like, for example, when I got my wisdom teeth out, I was in an experiment because I had experimental drugs. Now, I don't know if I was on the placebo or if I actually had the real medicine that they were trying for, right? Because they'll put you in different groups and see and observe how you act on these certain controlled substances or certain things, like they do certain things to certain kids, but the other kids they'll do differently. You know what I mean? You're in two different types of groups and then they observe you via that. Does that make sense? But a controlled one is, a lot of times is the person doesn't know what the survey is happening to them, but the person observing them is dictating what's happening. Okay? A lot of times is like what I talked about, a research one, like I got paid $500, by the way, so experimental drugs. Huh? Yeah, that type thing. And I was so cool back in 1997. Got my wisdom teeth out, 500 bones, got a pager for 3 days. A pager. That was legit stuff. I was all at school, and my guys, check out my pager. They were so jealous. You guys even know what a pager is? A pager was what they'd call your pager, and they'd leave your phone number, and you don't know who it is. They just say, please call me. Basically, the number comes up, and you're like, hey, I received a page. It was legit. Okay. Anyway, and I got to eat pudding for 8 hours, sitting in a chair, watching movies. It's great. Okay, a survey. Obviously, a survey is just a set of questions that you're asking somebody, right? Those are the 3 different types of study methods. So you're going to need to know the study methods, and you're going to need to know, what did we call these? Sampling types. Okay? Survey. Any questions? 8-3, we are done. Pretty simple, huh? Yep. So like number 1 of your question here says, identify the sampling method, and then identify any bias. A teacher committee wants to find out how much time students spend reading each week. They ask students entering a library. First off, that's a convenience. Is there a bias? Yes, because people going into a library probably read, right? Make sense? Then the back page talks about different sampling styles. Okay, 8-4. This is the one that we need to chit chat that I was talking about, more of the normal curve. Okay, 8.4. So the normal curve is what I was sharing yesterday about curving your guys' test scores, right? You guys remember that? Okay, so here's the normal curve. Now, this middle one is your mean, so your X bar. Okay? On a normal curve, what happens is it is separated into sections based on standard deviations. If I go out 1 standard deviation, both styles, okay, that means this whole data, I don't know if this color can really tell for you guys. Does that change colors for you? Okay, that one whole data means 68% of your data lies between 1 standard deviation. That is important. Okay, at 1 standard deviation, it's 68%. Now, for you guys that were in our class yesterday, it took us 3 standard deviations to cover our data, correct? Okay, because after 2 standard deviations, that's 95%. And after 3 standard deviations, remember how I told you I've rarely seen anything go more than 3? If you guys were in class yesterday, I talked about that. Because that covers, 99.7%. So it makes sense that 3 is most likely going to be what it could be. Now, in my 3rd and 4th period, I actually had 2 standard deviations covered our data, which also makes sense because that's 95% of our data should lie between 2 standard deviations. In our case over here, we only had 1 number outside of our data range after 2 standard deviations, correct? So therefore, that big A foot over here, you know, we had some issues on that, and that's why I took 3 standard deviations. That's why, like I was telling you though, that's why you never hardly, like I've only seen 4 standard deviation once, because it's so rare. That's 0.3% of your data outside of it. Not very much, right? Does that make sense to everybody? So the key thing here though is, as I'm bringing this up though, if this first standard deviation is 68%, how much is this side? He's 34 and he's 34, because they both should add up to be 58, correct? Now, what's the difference between 68 and 95? How much? 27, right? So guess how much this one represents? 13.5 and 13.5. Okay, and then notice what's the difference between 95% and 99.7%? 2.7. So each of these little tick marks right here are 2.35. So how much is left over? 0.3%, right? So how much is this last little part right here? 0.15, 0.15. Now let me explain kind of a question that they're asking. Okay? So we're going to go ahead and say, all right, let's say our mean was 75. Let's say this is your test scores. Our standard deviation is 5. Let's draw the normal curve. Okay? So what this means is I drew the normal curve. Bear with me, I'm not an artist, but I think it looks enough. It should be symmetrical. Okay? Everybody there with me? So notice, if this is 75, what's our tick marks for one standard deviation? It'd be 80 and 70. So that means if this was in relation to test scores, you could say 68% of our class had test scores between 70 and an 80. Make sense? 68%. Okay, what would be the next standard deviation? 85 and 65. Now let me ask you this question. What percent of the classroom scored less than 85%? So let's think about this. Okay, once again, how much is 2 standard deviations? 95%, correct? Okay, what is this little area right here? 34. How much is this little area right here? 13.5, right? Correct? Okay, so I'm looking for scores less than 80%. How much is this percentage-wise below this? Oops, sorry, hold on. 85%. How much is less than just 75%? How much of our class is less than 75%? 50, right? Because isn't our average the middle point? Right? So 50% of our people are less than our average. Okay? So therefore, how much did I say 80 or 85 first off? 85. So how many people, how much percent of our class scored less than 85%? Well, that's 50 plus 34. Now how much are we at? 84 plus 13.5. So total 87.5% of our data is less than an 85 score. 97, thank you. Thank you, sorry about that. 97, because I just added 50 plus the 34 plus the 13.5. Does it make sense why you also need to know each compartment of the standard deviation? Okay, so that we can justify through that. So, in our case yesterday with the shoe size with Gibby, because he was outside the second standard deviation, you were between second and third standard deviation, therefore his shoe size is 97.5% larger. I mean, there's less people than him in 97.5% of the class, which makes sense, right? Everybody with me on that? What would be the third standard deviation, just for kicks and giggles, just so we know what we're doing? This would be 60, and this would be 90. Okay? Does everybody understand how to use that data? Let's see. Yes, sir. So once again, your standard deviation is via your calculator. Everything's basically in this unit is calculator based. Now, like I was telling these guys yesterday, for those that weren't here, like I said, the average on this test is pretty high because this stuff, we're done basically. We're basically, like I was telling you, 90% average, because this test is pretty simple, right? The thing that people lose points on are knowing which type of sampling it is. Make sense? And misplacing one number on their calculations. Like instead of doing 30 numbers, they only did 29, so then they used that whole number set. Does that make sense? And I'm like, do I really know if they know what they're doing, or are they just writing crap down? Does that make sense? So that's sometimes the hardest part about grading this test, is because there's not work to be shown, right? It is very easy to lose points if you're not very meticulous in putting in your information. Okay, so once again, if you have a TI calculator, I'd hit Stat, Edit. Notice I have information in here already. I'm not going to enter more, but you'd put your information in. Notice, like I said, if you're going to do the L2, the frequency chart, you'd put it in the L2 column. Okay, so then I quit out and I go Stat, Calculate, one var stat. Like I said, if you are using the frequency table, you'd go here and you'd put L2, which L2 is right above the number 2. Okay, makes sense to everybody? But I don't have that in this case. I just put all the numbers in, so I just hit enter, enter, and it gives us all this information. X bar represents average. We're using the S of X, the sample standard deviation. So 2.93 would be the standard deviation. Variance is that number squared. Okay, and then do you remember box and whiskers? That information's down below. So it gives you your median. Now your calculator does not collect your mode, right? Remember how we talked about that? You'd actually have to find out what is mode, the thing that happens the most. Well, see, arguments, like we talked about this in class yesterday, there's people that believe if they're all the same, then there's no mode, but there's other people who believe that they're all the mode. Like, for example, on that data set that I have up there, I have 2, 2, 3, 4, 5, 5, 6, 6, 7, 8, or something like that. The mode would be 2, 5, and 6. I'm a person that says there's no mode because there's not something that's happening more than another. But for our classification, 2, 5, and 6 would be the mode. Yes. Then they're all the mode. And that's, to me, a silly definition, because to me there's no mode. Everybody with me on that? But like somebody said, when you see it on the frequency table, the one with the highest frequency is the mode, right? Okay. By the way, you can tell if something is normally distributed by, is it a normal curve? Like, that's a good normal curve. Sometimes your data is skewed. Sometimes your data is up here, like that. Does that make sense? That's called skewed left. Sometimes these, because maybe you have a lot of outliers over here, like we talked about Shaq walking in. Let's say if 2 Shaqs walked in, that's going to affect your average quite a bit. You know what I mean? Shaq and who's another big guy? Yao Ming, right? Come in and they're like, hi guys. Anyway, and they're right there. Their average, that's going to skew the average. Did we talk about yesterday if we increase, like if we went from American shoe size to European shoe sizes, what does that do to the average? We increase by that amount. So for example, I don't know how European shoe size is, but let's say my shoe size is 11. I just add 30 to it. Right now my shoe size is 41. And everybody just adds 30 to their shoe size, right? Does that change our mean? Yeah, what does it change our mean by? 30. Does it change our standard deviation? No, because the standard deviation's definition basically is the average distance away from the mean, right? Everybody's value would still be the same distance away from the mean, right? Did we talk about interquartile range? Does anybody know what interquartile range means? Interquartile range is Q3 minus Q1. What's just regular range? Max minus min. I don't know if I told you guys that yesterday, so I just want to make sure. Was that on your guys' homework at all? Might be on your test. But I've talked about it now. Yeah, which kind of makes sense, right? They could be two different questions. I don't think I have any more for you guys. That's it.